This program is made possible under a cooperative agreement with US EPA. This video tour was made possible by the Portage Lake Water and Sewage Authority, located in Houghton, Michigan. The Portage Lake Water and Sewage Authority serves the communities of Houghton and Hancock, as well as several additional smaller surrounding communities in the Upper Peninsula of Michigan. The wastewater treatment plant uses activated sludge to produce a treated effluent and digestion to produce high-quality biosolids. The plant has a design flow of 3.1 million gallons per day. The collection system includes 2 lift stations. The tour that you will see here was of the Houghton lift station. We would like to extend special thanks to 2 Portage Lake Water and Sewage Authority employees, Zane McKenzie, facility manager, who authorized the tour, and to Robert Lawson, laboratory technician and operator, who provided a guided tour of the Houghton lift station. In this video, we will talk about the purpose of lift stations, typical intake components including comminutors, bar screens, and level sensors, pump electrical control components, lift pump mechanical components, operation and maintenance tasks, backup power, and SCADA controls. I would now like to introduce Center for Technology and Training student intern Robert Davies, who captured the video footage of the lift station tour. Robert will help us to clarify some additional information regarding the purpose and functions of the lift station.
Hello, and welcome to the Houghton Wastewater Lift Station Tour. The first stop on our tour is the intake area of the lift station. Here, Bob Lawson, the operator, shows us the comminutor and the bar screen systems. The comminutor serves to break up large solids and rags before entering the lift pumps, before moving on to the wastewater treatment station. The bar screen system is there as a backup for the comminutor, where it will filter out those same solids before entering the wastewater stream if the comminutor is down for any reason.
We're gonna take a tour of where the water actually comes into the main pump station for Houghton, and see the manual bar screen and the muffin monster that the water flows through. There's a series of floats in there as well to maintain flow and to be sure that the water is moving in and out efficiently. So the water is actually coming in. Water is actually flowing in here right now at approximately about 400 to 500 gallons a minute. It's being diverted through this channel, which is our main channel, where it goes through the what we call the muffin that the flow is being diverted into to dry up any material that was flowing through it. You can see those rotating drums and the teeth in behind them. If it builds up higher than the cutout, it would flow through and manually get screened and raked up through the manual bar screen. The actual flow, and you can see the buildup of grease and things. That's why it's important to have grease traps and stuff throughout the city cleaned out too, and a series of floats in there as well. The floats are, for the most part, used as a backup supply for level control.
The muffin monster comminutor grinds solids and shreds rags into smaller pieces so that the pumps are not damaged and piping does not become clogged through the course of wastewater treatment. Also within this intake area is a series of float switches. These float switches help command when the pumps turn on and when the pumps turn off. So as the water level increases, the pump switches are increased sequentially, allowing more and more pumps to be turned on. When the water level lowers, the pump switches disengage, allowing pumps to turn off and only be operated when commanded. The float system that we see on the left here is the backup system for the Portage lift station. What the Portage lift station uses on a common system is the transducer system, which is simply a pressure transducer that is measuring the water pressure above that sensor. The higher the pressure, the more pumps are turned on at a predetermined value.
Here, what we call a hydropack, is the actual pump, hydraulic pump that's operating the muffin monster. It's turning the teeth of the muffin monster in the channel. So this is a couple of grease fittings on the motor periodically, have to be serviced. The fluid inside the pack itself has to be serviced in proper levels. There's alarms for grinder jams, things like that. We'll be notified at the plant if the grinder is jammed or if it's low on oil. So quite a few different alarms as well. But it will sense the jam of the grinder. It will try to throw it back out whatever's jamming it. We'll try to throw it back out 3 times, and then if it still is jammed after that, then it goes to an alarm that calls the pump. So we know that something's in there, either a big rock or something that's too hard for it to chew it up. So we'd have to come manually pick that out.
This section will go over some of the basic grinder controls for the lift station, as well as some of the existing PLC systems for the lift station regarding the Muffin Monster comminutor.
Control for the Muffin Monster that's in the wet well. This would technically let you know if you are low on oil pressure, temperature, motor overload due to the grinder being jammed. And this is actually where the alarm would sound if there was an alarm jam in the grinder itself. So, another hands-off auto, you can run in an auto, which auto basically runs it all the time, but it would let it kick some, if there's debris in there that's grinding or that's jamming the grinder. In auto, that grinder would automatically try to reverse itself 3 times to clear the jam. In hand, it basically runs all the time no matter what's coming.
This next section, Bob Lawson talks about the pump control systems for the Portage wastewater lift station. These pump control systems include the pressure transducer, the flow recorder, an hour meter, the hand off and auto switch, and the variable frequency drive speed controller for the pump motors.
So in here is the main control panels for each variable frequency drives for each pump. All the circuit breakers obviously to be able to eliminate power if we had to lock the pumps out to work on them. Over here we got a circular flow chart that we monitor power usage, flows out of the lift station. They're not measured coming in, but they're measured going out. But realistically, whichever is coming into the lift station comes out. So we just measure the flow that leaves the lift station. Switches for each pump, reset buttons for any alarms that would go on. Inside the panels, the PLC that's programmed to run all the transducers and the speeds of the pumps. Radio for alarm systems. We've got high flow, or high wet well, excuse me, not high flow, but high wet well alarms. We've got low wet well alarms. We've got power fail alarms, and pump fail alarms as well. So if the pumps would trip out in any way, we'd be notified at the plant certain hours of the day, and after that we'd be notified at home as well. So
could you share, Bob, what kind of information that the operators record from this panel?
Sure.
And how do you use it?
We record the hours readings. We use that for a certain amount of hours for greasing the pumps and the motors and things like that. We've got the main flow. This is gallons per minute that's coming in, or that's leaving the lift station at about 400 gallons a minute. This is our totalized reading that we take every day to get the totalized flow for the day. And so the main panel, Allen Bradley panel here, shows us the level of the wet well. It'll show us the percentage of the hertz of the pump that's running. And we can go through and see the speeds, different speeds of the pumps, the levels, a little bit of control of the operator being able to control levels and speeds of the pumps and things like that.
So right now it looks like one pump is running and the other, that's the lead pump, and the other 3 pumps are stopped. But will that alternate at some point?
Every 6 hours. So the PLC will switch it out, drop it out every 6 hours. If the flow gets to a certain stage, if we went to this would tell us that we would get a step 2 on flow at about 5 feet. So if the level of the wet well gets up to 5 feet, which is currently at 4.1, that would kick the second pump on to maintain level at that, and so on and so forth for all 4 pumps. So.
This is an example of one of the hour meters on the pump control board. Each pump has its own hour meter, which is important to use for maintenance and ensuring that pumps are being equally balanced. The hand-off auto switch and light indicators are part of the PLC control systems, showing if the pump is running under control or if it's running in hand mode, where it will just be running continuously. Moving on to the variable frequency drive panels, these are used to control the RPMs of the pumps. The pumps should not be running at full 100% speeds at all times and should be monitored and driven according to the level of water in the wet wells.
So these panels, each panel is specific to each pump. It's got a handoff auto switch, which basically means you can run it in manual mode, or you're currently running in auto mode by the PLC. So this would monitor frequency output as far as amps, voltage, RPMs. You can set your minimum, your maximums, and what this panel actually does, there's an inverter inside here that adjusts the speed of the pump for the flow, and that eliminates the constant on-off of the pump due to a float, and it really tends to be more energy efficient in the long run as far as being able to avoid the demand charges, the constant on and offs of a float operated pump. So these will go down just about from 200 gallons a minute at the minimum, all the way up to approximately 2,500 gallons a minute at the maximum. And then there's a backup float system. If it goes more or higher than that, the backup float system would tend to kick more pumps on and off if there was problems with the inverters.
Moving on now is to the pump room where the 4 pumps for the lift station are stored. We will discuss the wash water system for the seals, check valves to prevent backflow, the flow meters to monitor flow rates, coupling, impeller adjustments, and the maintenance schedule that Portage lift station uses for these pumps.
That move the wastewater from the city out to the main treatment plant. The Aurora pumps can pump approximately 2,500 gallons a minute each. So this lift station itself can handle approximately 8,000 to 10,000 gallons a minute of water. Got mechanical seals in them. There's no stuffing, no packing in the stuffing box. These are all mechanical seals in these pumps. We've got to keep track and keep up on the couplings that are between the motor and the pump as well. Different times if they get over torqued, they'll break, or just then wearing over time, they'll strip out and have to change those. We want to monitor the wash water that goes into the mechanical seal. So we know we have good wash water in between the seal and the wearing seal piece to keep the grit and stuff out of there. Mechanical seals are very expensive.
Is that clean drinking water that goes in?
Oh, that goes into the seal? It can be, but technically it's basically pumped from lake water just to reduce costs of buying the water. So they're pumping in about a gallon a minute of fresh water or non-potable water to wash the seals. So if you did that 1,400 minutes a day, it's about to be a lot of gallons of water just to wash the seals over a month's time. So we use lake water 99% of the time.
That eliminates your risk of having a cross connection.
Yeah, well, if this system goes down and the pressure regulator upstairs sees that pressure drop, it will let water from the city come in. But there's a series of backflow preventers and stuff to eliminate that cross connection. So at the top of the pump, vertical shaft pumps. We got the motor that feeds it. These motors have to be 100 horsepower motors. Between the motor and the drive shaft of the pump itself is a coupling. So that coupling tends to be the weak spot. If something would come in and jam the pump, or if the pump is really out of alignment, then that would tend to chew up that coupling, and the motor would spin, but the pump wouldn't. So that would tell you that you have to service the coupling in between there, a flexible coupling shaft. And then so the main motor would drive the pump down into the impeller inside of the volute. The impeller is spinning at a centrifugal motion to stow the water to the outside of the volute that forces it up through the check valve and out to the plant. We got up on top of there, you can see the actual mag meter, flow meter. Where the water is going through that is what is actually being measured up on the circular chart.
The check valve allows water to only flow in one direction. The picture here is an example of one of the check valves within this location. If the check valve were to stick open, water would be able to flow backwards through the pumps, and which will result in lower efficiency. Or if the check valve becomes clogged, it will also restrict flow out of the pump. These check valves need to be periodically inspected and cleaned, and should be part of a maintenance schedule. Around the pump room, there are several pressure gauges, mostly regarding to the pressure that the pump is outputting. This helps operators know that pumps are operating within normal range and there are no obstructions or leaks in the piping for this system. Around this pump room are a bunch of air release valve switches. The purpose of these switches, as the name implies, is to release air trapped inside of the pumps. This helps with the efficiency of the pumps, as well as preventing damage due to cavitation or other problems of running a dry pump. There are also 2 flow meters in the pump room area that are used to determine the flow of wastewater being sent to the treatment plant. This is used to help ensure the pumps are running efficiently, as well as understanding the amount of hours those pumps have ran and worked. One important note about these flow meters is that they are magnetic flow meters, so there are no moving parts that are able to be obstructed by wastewater, as you would find with an impeller, flow meter, or any other kind of flow meter. The Portage lift station has a maintenance program that they keep track of using several clipboards like these on the wall. The clipboards have the hours and what sort of maintenance was done on those pumps, so that any operator can go to the clipboard for the specific device and ensure that that piece of equipment is up to maintenance standards and has not been overdue for any sort of maintenance. Some maintenance tasks that are common for these systems include lubrication, checking the impeller clearances, electrical measurements, and inspection of check valves and couplings. Moving on now to the backup generator room for the Portage lift station.
So in the event of a power fail, we can still pump the water out to the main treatment plant. So each lift station and the main plant all have their own auxiliary power sources. So this is size such that will run all 4 pumps and all the equipment that we need to run to effectively pump the wastewater out to the plant.
Is this a natural gas pump?
This is actually fuel oil.
Oh, fuel oil.
Yeah. So it was just replaced a couple of years ago, actually. I'm not quite sure if they didn't study the switching to natural gas or why that, but it's currently fuel oil. So always has been. So even the old ones. The operator, as far as the mechanic, we do keep track of hours on the generator, and every so many hours we change the oil, the fuel filters, the antifreeze filters, monitor hours we use through the main panel, and also if there's any alarms, the generator would show any alarms that would show up on this digital screen as well. So.
Does this have an automatic transfer?
Yes, that's what all this stuff is over here. So if it senses a loss of power, it automatically starts the generator, and once it's up to speed, the generator starts putting out power, then everything switches over to that and is ran by auxiliary power.
Would this panel be one of those a danger of arc flash?
Absolutely, any electrical panel is a danger of arc flash, and that's a big deal. People get hurt very bad, so it's a good idea to have training on arc flash as well. Proper lockout, tagout procedures, things like that. Personal protective equipment, that's all falls under that arc flash stuff, and very important.
This is a close-up of the generator control panel. The main things to note on the generator control panel is the LCD display, currently showing engine hours, the emergency stop button, as well as the basic monitoring system for the operator to see how the generator is running during a power outage scenario or any other time the generator is running. Finally, we returned back to the water treatment plant and logged into the SCADA system. The SCADA system is the main control center for all of the wastewater operations at this site. This allows for the remote operation of the lift station from the wastewater treatment center itself, instead of having to go out and driving these mile or so to the lift station itself to do any settings changes.
So this now is our SCADA control panel. This is what's coming actually into the plant. So it's combined lift station flow and the gravity flow, which will basically come from Michigan Tech out this way, or Franklin Square. And so we can monitor what we just saw at the lift stations, which pumps are running. We've got a series of alarms over on the right side here for our power failure. Basement flooded alarm, which would basically tell us if our little sump pumps for our air release vents are working. We get a wet well high level and a generator running alarm. So if we have a power failure, that'll show up out here as well. We can see the gallons per minute that's leaving the lift station is a 436 gallons per minute, and our wet well level is 4.1 feet. The red pumps are the ones that are off, and the green pumps are the ones that are running. So we currently have one pump running at each main lift station.
We'd like to thank you for watching the Portage Lift Station tour video. Thank you.
Thank you, Robert. The Environmental Finance Center Network provides technical assistance and training for water and wastewater systems. If you are a public wastewater utility with a flow of less than 1 million gallons per day, or a drinking water system serving less than 10,000 persons, you can qualify for no-cost technical assistance for technical, managerial, financial, or compliance-related issues. To register for no-cost workshops, access helpful resources, or request technical assistance, please visit us at www.efcnetwork.org.